VMware guest-based high availability clusters, ways to protect SQL and maintain flexibility. Our speaker today is Dave Birmingham, who's a Microsoft clustering and data center MVP. Today he will discuss how to protect SQL Server in a VMware environment. During the webcast, we encourage you to ask questions. To ask a question, enter your question in the question area in your presentation controls, and we will try to answer as many questions as possible during today's webcast. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Tim. We're going to be talking about high availability for SQL Server in VMware today. At the end of the presentation, my coworker Tony Tamarchio is going to join us for a little information about SIOS technology. My name again is Dave Birmingham. Been a cluster MVP for about 6 or 7 years. Recently transitioned to Microsoft Cloud Data Center MVP. And in my role at SIOS Technology, I've been helping people build high availability configurations for the past 13 years. So that's kind of my focus is in that HA area. So let's get started. The agenda we have today, we're talking about 5 ways to provide the high availability. We're going to take a look at VMware HA. We're going to look at VMware FT. We're going to look at the SQL Server always-on availability groups. We're going to look at SQL Server always-on failover cluster instance, and then we're going to look at SQL Server SANLess cluster using the SIOS DataKeeper solution. So let's talk about VMware HA. We're talking about VMware HA, but this really applies to any of the hypervisors that have high availability kind of baked into the hypervisors. So VMware HA, Microsoft with the Hyper-V, which would be the Hyper-V cluster. Same concept that really applies to any of the virtualization platforms. So what VMware HA is going to do is really protect you primarily against the failure of the host. So in any virtual environment, you have the physical server called the host that's going to host one or more virtual machines. And so in the case that your physical server fails, virtual machines that were running on that physical server will be restarted on the secondary server from a cold reboot. So there's no automatic failover. Those virtual machines that are going to recover have to be started from scratch. So you'll see the virtual machine starting up, Windows starting. SQL Server will have to recover those databases. It's like someone came up and yanked the plug on your server. So they're going to have to do a soft recovery, roll back any uncommitted transactions. So your recovery time objective is probably closer to, 2-3 minutes or even longer, depending upon how long it takes your virtual machine to start up and what was going on with SQL Server at the time to recover those databases. In certain circumstances, it could take much longer. So VMware HA is great for those host-based failures, but your recovery time objective is not as good as you might expect from some other scenarios. So if you have a failure of the guest, so if it's simply a virtual machine that becomes unresponsive, VMware HA can detect that type of failure as well. So it's going to detect that virtual machine as a whole just has become unresponsive, and will take recovery action on that virtual machine to restart it in place. So it can recover from a virtual machine just becoming hung up and not responding at all. Inside the virtual machine, if your application fails, if you enable something called App HA with VMware HA, so you can get some level of application monitoring, detecting if service is running or not. And the application HA can detect that type of failure, and what it can do, it can restart the application, right? So, or if the restart doesn't fix the problem, it can reset the VM in place. So it'll restart that, reboot that VM, and hope that the application will come up in a more usable state. And all this is triggered. You can trigger through the vCenter to send an alarm or send an email notification if your application is having a problem. So that's an extension of VMware HA for the application specifically. So in summary, VMware HA is easy to configure. You just kind of turn it on and build your cluster. The beauty of VMware HA is application and guest operating system agnostic. So any workload can benefit from your VMware HA. It doesn't have to be cluster aware. It doesn't have to be Windows. It could be Linux. It could be whatever operating system is going to run on your virtual platform. You can have some level of availability for it. It's great for recovering from failures of that host. If your hardware fails, it's going to be able to restart those virtual machines on another instance. Well, some of the limitations you have limited application monitoring. So it's not very in-depth monitoring and recovery of that application. You have some limited options there in terms of application level failures. The big thing that many people don't really think about, and when you think about downtime, I mean, how often do you have unexpected downtime from a hardware type failure or some sort of system level failure or software based failure versus how much downtime you have for planned maintenance? You're typically applying some sort of update, at least on Windows, monthly at this point, or service packs for SQL, much more extensive outage. There's no, with just VMware HA in place, you have to schedule that downtime. So your application, your SQL Server is not going to be available. So it doesn't address that planned maintenance period. So there's no, VMware HA does not solve that downtime, right? And the recovery time objective we saw, it requires a restart of the VM. So you're not going to have that second type of recovery. You're going to have recovery that's more in the minutes, multiple minutes range because of the complete restart of that virtual machine. So let's jump over to the next option, VMware FT. It's been around for a while. It's very limited in supportability for a long time with some limited CPU support. It's a little bit better now. But what VMware FT does, it takes the concept of VMware HA and extends it so that if you have a failure of that host operating system, those virtual machines are actually running in lockstep on another secondary server, so that doesn't require a complete restart. So the users will not be disconnected. The application will continue to run, and you're going to have no downtime. So that's much better user experience, a much better recovery time objective than the VMware HA solution, right? But it does have its issues as well. So the benefits, again, the seamless failover, same as VMware HA, it's guest operating system agnostic and will protect you in case of hardware failures. Once again, has very limited application monitoring. It's not going to do much if your application starts to behave badly. There's no really recovery mechanisms for that. And once again, it doesn't address that planned maintenance, which in my experience is the culprit of most downtime. Whether or not you call it downtime or not, it's still your application is unavailable when you're doing that planned maintenance. With fault tolerance, you have some limitations in terms of the number of vCPUs per host that can be supported and the amount of RAM that can be supported. So make sure you read the latest release notes of the version of VMware that you're using to see exactly what's supported with your version of vSphere. So you definitely want to be aware of that. There's limited support there. And of course, it does not protect against OS failure. So if the OS fails, it doesn't matter if you have another OS running in lockstep with a backup server, it's going to be failed over there as well. So that's another limitation. And then finally, this solution requires raw device mapping to your shared storage. I just failed to really mention the VMware HA and VMware FT both require that your virtual machines reside on a SAN, some sort of shared storage. In the case of VMware FT, you have to actually enable raw device mapping for those virtual machines, which is going to limit some of the options you have in a virtual environment to do things like take snapshots and so forth. So just be aware of that if you're looking at the VMware FT solution. So SQL Server always on availability groups or short, always on AG, you might see called that as well. SQL Server Always On Availability Groups was introduced in SQL Server 2012 Enterprise Edition, and what it does is allows you to do replication and some amount of high availability for user-defined databases. So if you have your databases that you've built and you want to replicate them from one instance of SQL to another instance of SQL, you can configure an always-on availability group and put your databases in that group, and they will replicate either synchronously for local replication or asynchronously for disaster recovery. Excuse me. But what it does is, if there's once again, if there's a failure of the application or the entire server itself, all those databases that you protected and put in the scheme, the always-on availability group, if you enabled synchronous replication with automatic failover, those virtual machines will start running on the secondary instance of SQL Server. And starting with SQL Server 2016, it actually goes a layer deeper and can monitor the health of the database as well. So before SQL 2016, if your database became suspect, it wouldn't fail over. With 2016, you can enable that database monitoring, so you can actually recover from a database level issue as well. The good part of this solution is that the recovery time objective is very good, because SQL Server is already running on that instance. The databases don't have to go through any sort of cold boot and roll back unlimited transactions. So there's a very good recovery time objective generally, and the user experience is pretty good. The user is going to be redirected to that instance pretty quickly. So the benefits, they mention this, but you can also enable any secondary copy of your database as readable. So depending on the version of SQL, you can have multiple copies of that database available to run reports or do backups or anything like that. It has a very fast failover, once again, because SQL Server is running on that secondary server. And it will recover from hardware-based failures, applications failures, and it eliminates the need for a SAN, which eliminates the SAN as a single point of failure, but also lets you start leveraging some really cool new storage, whether you're looking at some flash-based PCIe flash-based storage, or some of the new RAM that you'll be able to use for really super screaming low latency storage, but still have some failover capabilities. So what are the limitations of always-on availability groups? Up until 2016, you were limited to one failover partner. With SQL Server 2016, you can now have two failover partners. So that's one of the improvements there. It does require the Enterprise Edition in SQL 2012 or 2014. In SQL 2016, they introduced something called a basic availability group, which allows you to replicate a single database in an availability group. So it gives you some protection with standard edition, but it's very limited in terms of scope, and it doesn't support things like readable secondary. So it's really built to kind of try to replace database mirroring, which has been deprecated for the past few releases, and I know Microsoft wants to try to get that out of the product. One of the big technical gotchas that people run into, besides requiring the Enterprise Edition, which is a cost prohibitive problem, is the technical reason it doesn't support distributed transactions. So if your database can, uses distributed transactions across multiple instances or multiple databases, you're not going to be able to use the always-on availability group feature in SQL 2012 or 2014. If you read the marketing material for SQL 2016, you might think that this is fixed in 2016, but you're going to want to go and read the fine print. It has some support, but the support that it has is assuming that your distributed transactions take place across different SQL Server instances. So they can't take the place across databases in the same instance or even databases within the same availability group. So it does have some support, but it's not quite ready yet to be fully supported, even with SQL 2016. And the other big thing, it doesn't replicate any of your system databases. So user-defined databases are fine, but your master, your MSDB, and everything else are not replicated. And so what that means is you still have to manage each instance independently. So all your agent jobs, your logins, your passwords are all you have to manage independently across each SQL Server instance, which it adds to the administrative overhead. As you add databases, you need to adjust your availability group scheme, and as you drop databases, you need to keep on top of that. So there's some additional administrative overhead in addition to maintaining your system databases on two different instances. Up until 2016, they had a really pretty glaring performance issue once you start pushing the write throughput to the higher end. If you were looking at using PCIe flash storage and you were really doing a lot of write throughput, you would notice that when you turn on synchronous replication, your throughput just dropped tremendously. So the log transport had a single thread issue that was causing a tremendous amount of slowdown. Now with SQL 2016, they've improved that as well. So just keep that in mind. That the overhead, especially on those earlier versions of SQL Server, if you're doing any sort of synchronous replication. So this takes us to the always-on failover cluster instance, which is really your good old-fashioned failover cluster with a SAN, which has been around. This has been, the original high availability solution for SQL Server and many other applications for many years. This assumes that you have some sort of shared storage device, so a fiber channel SAN, an iSCSI target. It can support, you can put your databases on a scale-out file server, connect to it over SMB3, but it still requires some sort of shared storage device where all of your databases sit. There's only one copy of your database, and what happens is the failover cluster will control who has access, which node has access to those files. And so the good thing about failover clustering, it monitors at the application layer, so it will detect problems with SQL Server. It will detect problems should the entire instance fail, so your entire virtual machine will fail. It will detect those types of problems. And again, if the whole host server fails. So it gives you the most robust monitoring and of your application stack of all the solutions. So if there's a failure of any one of those pieces of the puzzle, it will basically allow the secondary node to have access to those databases, will start up SQL Server, and will redirect your clients to that node and will keep running on that server. So what are the benefits of the failover cluster instance? One of the big things, it protects the entire SQL Server instance. So as we mentioned before, always-on availability groups is limited in scope to just the user-defined databases. With the failover cluster, you're going to get the entire instance, all your system databases, your agent jobs, your logins. Everything is going to fail over as a single unit. And really, to the end user, they don't even know that their failover has occurred because the instance name is exactly the same. It's a clustered instance name. So there's a virtual computer object that's created which your clients connect to. It's been around for quite some time, so you're not going to have to worry about your application supporting it. Again, it's widely supported. It's your application really shouldn't even know that's connected to a clustered instance, whereas in the availability groups, not totally supported across every application. So you really need to take a look at your specific application to know whether or not it would be supported. Failover cluster is going to be much more widely supported and recovers from all sorts of failures, from the host to the guest to the software or the SQL Server. It has much more robust application monitoring. So what are the limitations when you're talking about running a failover cluster instance inside a virtual machine in VMware? The biggest limitation that people have is it requires the raw device mapping of the physical disk. And by requiring the raw device mapping, that's going to preclude you from using a lot of the features of VMware, including you're no longer going to be able to do snapshots. You're not going to be able to use vMotion to move those virtual machines to a different host. You're not going to be able to support DRS, so there's no bouncing of those virtual machines. So recovery manager is not going to be supported, so you're not going to have any of that. And the SAN becomes a single point of failure. So for these reasons, primarily these first reasons, many VMware administrators are in kind of a battle with their DBA. DBA just needs to ensure availability. They want to have the best availability possible. So they're looking at something like a failover cluster. The SAN administrator and the virtual, the VMware administrator are like, no, you can't do that because you're breaking everything that makes my job cool. So there's this kind of battle going back and forth. So you're gonna have to fight that battle if you want to try to do failover clustering inside of a virtual machine in VMware. And then, of course, the SAN itself, you really need to make sure that your SAN is fully redundant. You're not having any problems with that SAN because the SAN itself as a single unit can become a single point of failure. And this limits your high availability because of the SAN sitting in one site really to a single site recovery solution. So you can't stretch this across sites as you could with the always-on availability groups. You could have asynchronous copies further out for disaster recovery. So that leads us to the final solution we're going to talk about today, the SQL Server SANLess cluster. A SANLess cluster is a terminology that SIOS uses to describe a failover cluster that utilizes host-based replication solution called DataKeeper to allow you to build a traditional SQL Server failover cluster instance, but instead of requiring a SAN, it allows you to leverage just local attached storage. So whether you're building a SAN with physical servers and some PCIe flash storage, or you're doing virtual machines, or even cloud instances where shared storage is not an option, the SANLess cluster is going to be a great alternative for you. So really what it is, it's a failover cluster instance just like we just saw, but it eliminates the SAN as a requirement. So you're still going to get the same deep level of application monitoring and system monitoring for the guest and the OS, and you're going to have recovery of the entire instance just like we saw with the failover cluster instance, but you're not going to have the same limitations that the SAN puts into place. So your VMware administrator is going to be much happier with this solution. So once again, the benefit is it protects the entire instance. It leverages the industry standard, high availability solution. It's going to be a failover cluster instance, nothing more, nothing less. So it gives you the same deep level monitoring, hardware, software, application layer, and supports all those features that we saw were broken with raw device mapping. So your VMware administrator is going to be much happier that he can support all those cool features. The only limitation in that it does not support a real-time read-only replica like we saw with availability groups. You're limited to a point-in-time snapshot of the target data. So you can have access to that data, but it is point in time, so it's not going to be continuously updated. So you'll have to kind of schedule snapshots if you want to leverage the data on that target system to do month-end reports or something along those lines. This chart really just kind of summarizes what we talked about earlier. It's a great kind of one slide sums up the whole thing. You have the 5 different options, some features, which option supports what feature, and so you can get a good look here. Of course, the option on the far right is my favorite. I'm biased to work for SIOS, but it is actually a great solution that's going to give you the high availability that you need, the deep application level monitoring, and your VMware infrastructure guy is not going to be upset with you because you're not breaking all his VMware features and functionality. So with that, I'm going to turn it over to Tony Tamarchio from SIOS, who's going to give you a quick demonstration so you get a feel for how the SIOS Datakeeper product works and integrates with failover clustering.
Excellent. Thanks very much, Dave. A great overview on all the different options you have within VMware to protect SQL Server. So I just want to take everybody through a quick demonstration and really build upon the foundation that Dave has set here today in the webinar. And we're going to be looking at a SANLess cluster where we're leveraging a SQL Server failover cluster instance. But here we're using Datakeeper to perform real-time continuous block-level replication between virtual machines, which eliminates the shared disk requirement from a traditional cluster. So again, this really expands upon all the great benefits of a traditional failover cluster, but it eliminates one of the biggest challenges, which is that shared disk, which typically means you're having to deal with things like raw device mapping. So it's really the best of both worlds. So here I have a typical cluster. This is a 2-node cluster. You certainly can do more than that. And if you've ever set up a SQL cluster in the past, 99% of this is going to look familiar. There are a couple of differences here that'll take you through and show you how easy it is to set this up. So the first thing you might notice is that we have a slightly different witness configuration. So in a traditional failover cluster, you would generally carve out a small LUN on your SAN, and that would be your quorum disk, or now it's called your disk witness. Well, in a configuration where you don't have shared storage, you can't use a disk witness. So the failover clustering also provides a feature where you can use a file share witness as one of the votes within your cluster. So that's one difference from what you might be used to. And the second biggest difference is that there aren't any shared disks between these two cluster nodes. So this cluster is made up of 2 systems called SIOS 1 and SIOS 2. These are just virtual machines. Each VM has their own unique VMDK files, and Datakeeper handles the real-time replication to keep the data in sync. So because of this, you're not going to see what Microsoft calls physical disk resources, and those would be the shared LUNs on your SAN, whether that's raw device map LUN, or it could be an iSCSI target or things like that. And instead, Datakeeper is providing what Microsoft calls a third-party storage class resource. Here we have these Datakeeper volume resources. And I'll show you how we create that in the demonstration. If you look at your actual your clustered instance of SQL Server, again, this basically looks the same. You've got your network name, you've got your IP, you've got your SQL Server resources, and then instead of that shared disk resource, we have a Datakeeper volume resource. And the way that you get those Datakeeper resources into the cluster is using the Datakeeper user interface, which is a very easy to use MMC snap in here. You fire it up and you connect to both machines. And the first thing you'll see here is I've brought up a server overview screen, and this shows me the servers that I'm dealing with. So again, they're called SIOS 1 and SIOS 2. And I already have a couple of mirrors created, but we're going to create a brand new one here for you live on the webinar here today. So here I can see the different drive letters that these systems have, if they're involved in a mirror already or not. So I've got mirrors for K and for S already. You can see what the role is, what the mirror state is. And I've got an extra drive letter here, R. We're going to create a new job and set up a new mirror and have that added into the cluster automatically. So to do this is quite simple. It's a 3-step wizard. We're going to go in here. We're going to give this job a name. So I'll just call it R drive. And in the 3-step wizard, first we're going to select our source, next the target of the mirror, and finally our mirror options. So the source in this case will go with SIOS 1. If you do have multiple network interfaces, you could decide which network you use for replication. As a best practice, you usually want to separate your replication traffic from your user, your client access traffic here. So I've got this 10.10.10.10 network that I use for replication. And then you're going to go ahead and select the drive letter that you want to replicate and click Next. Step 2, you select the target. It's pre-populated all of these drop-downs for me automatically. It's selected the other machine. It's selected the right IP address, and you know, we're gonna select the drive letter here. And then finally, on the next screen, we're going to go ahead and select our mirror options, and this is where you can decide, you know, if you want to enable compression, and that's typically done if you are doing, let's say, a geo cluster. So again, one of the benefits of this is because there's no shared storage. You know, you could have these two VMs in different data centers, you know, in different countries. You have the ability to replicate the data both synchronously and asynchronously. So typically, if you go with synchronous replication, you'll typically use that if you've got a high-speed, low-latency network between your cluster nodes. LAN type configuration, and if you want to do a geo cluster, that's generally where you would go with asynchronous. You also can do throttling. So you know, you create this new mirror through this wizard, and the end result is it goes ahead and it dumps the disk resource into the cluster. And when you then install SQL Server into the failover cluster, you know, you fire up the SQL installation wizard telling it you want a highly available instance of SQL Server. You go through the wizard, and halfway through it'll ask you which cluster disk you want to use. You just check the box next to the particular data keeper resource that you're interested in protecting here. And from there, you know, this is really just failover clustering 101. You know, if you really didn't dig down deeper, you would know that you don't actually have shared disk. And if and when failover takes place, it automatically flip-flops the direction of replication, as you saw in some of the diagrams that Dave went through here. So, you know, just to summarize, you know, really this, you know, gives you the best of all worlds here. You know, it's providing full stack protection. It's protecting against outages at the hardware layer, at the VM dies, if there's an issue with the operating system, or if the application fails. It's providing you with full instance level protection. There's going to be less administrative overhead than things like availability groups, because you have a single highly available instance of SQL Server instead of two standalone instances, and it's protecting the full instance, you know, your system databases and everything like that. You also don't have to worry about, you know, things like CPU and memory limitations like you would with other technologies like VMware FT. And this also eliminates, you know, the operating system as well as the disk as a potential single point of failure, and it's compatible with all applications. So, you know, that's just a quick demo. Again, 3-step wizard. You know, if you've ever set up a failover cluster in the past, you again know 99% of how all of this works. This just, you know, expands upon, you know, the great functionality that you get with traditional SQL clustering, but it now provides you with the flexibility to, you know, deploy this in configurations where, you know, you no longer need that shared disk between nodes, so you don't lose VMware functionality. It opens up, you know, the options to do geo clusters and compatible with all applications, and lots of great benefits here. So, you know, with that.
I was going to say something. I think I maybe forgot to mention that the other benefit of this solution, the cost benefit, you can do this to a SQL Server Standard Edition. You can have a 2-node cluster and save a lot of money over the always-on availability groups, which is going to require the Enterprise Edition.
Yeah, most definitely, most definitely.
You know, if you have questions, I think we have a question and answer tab in the console here.